Hi, it's Jocelyn. In this series, we're building a voice journal and audio analysis toolkit for people who want to change the way their voice comes across. And in the first episode, we started working on a command line clone of the Voice Memos app on Apple platforms. And we ended up with a command line app which can record and play back audio clips and saves them to an SQLite database. The way we left it off, it does work, however, our encoding is very inefficient. We're just taking the raw audio data as 32-bit floats and writing those directly to disk. So that is 4 bytes per sample, and then we have around 48,000 of these samples per second. So you can see already it just gets really crazy. Fortunately, there are lots of excellent compression algorithms which we're going to use. One that looks particularly promising for us is opus. But first of all, I'm just going to go a little bit over the encoding and decoding ecosystem in Rust. So there is a crate called Symphonia, which is pure Rust, which offers pure Rust audio decoding. So we're going to look at this when we're interested in importing audio clips, but this does not offer encoding. And in fact, there's not really any pure Rust audio encoding crates for compressed formats. And there's one called Hound for wave formats. So this might be good if you want to export wave, but for actually storing data, we want to be a little bit more efficient. So we'll want something more like opus than like wave. So when there's not a pure Rust crate for something, we can look at things written in C and wrappers around those. So if you're coming from a C background, it's no worse to use a C library in Rust than it is to use a C library in C. There's a project called BindGen which helps make unsafe Rust types for your C library. But in a lot of cases, somebody has already done this for you. But when you're looking at these libraries, there's a huge range of qualities. So we looked at rusqlite, which is like an extremely high quality binding around the SQLite library. And then on the other hand, you're making something yourself. But when you're looking at crates somewhere in the middle, it's important to realize that you can't entirely ignore the C library. You have to know what's going on, or you may have to know what's going on. You may have to look into it just because the quality of these libraries is not necessarily as high as you're used to if you're using any of these main crates. In terms of the Rust ecosystem, there's not a ton of encoding libraries or encoding crates, even around, or even like wrappers around C libraries. But what we're going to look at today is audiopus, which is a high-level binding of the opus codec library, this thing. What it does is it takes packets or frames of audio data, which are, you can decide, but they're around 20 milliseconds, and encodes those in opus. So this doesn't give you like an opus file. It just gives you these packets or these frames. If you did want to make an opus file, that's actually like an OGG container that contains these frames. Just so for some terminology here, this is a little bit more low level than something like lib opus file or something. But this is what we're going to look at. They also are about to release a 0.3.0. The main difference here is that in the previous versions, they used their own try from and try into traits before those were stabilized, but now those are stabilized, so they just use the standard libraries version. So we'll just add this to our cargo.toml. All right, and the builds, oops. All right, and then the first thing I like doing is looking for examples. There are actually no examples here. In fact, there's an issue for that, where the author mentions that this is a project that they use in another crate that they're working on. So we can look over here and see, like, okay, the opus encoder is used like in cache compressors, so we can look at that. The other thing I like doing when I'm new to a library and I want to see examples of it is I just use grep.app just to search across GitHub. So like you can search use audiopus. And when I was looking through these, I saw that most of the use cases for using audiopus were for like VoIP applications, which makes sense. Opus has really good quality at any bit rate, but it's particularly well suited for VoIP. The one thing that is not a VoIP application, though, and is therefore more helpful for us likely, is the OGG opus project. So this actually can be used, this crate can be used to make like opus files. And so we could use that directly. However, this section kind of scared me. Like the fact that like so many of these things aren't really tested, and the fact that it doesn't support or directly support floating point numbers, so we'd have to convert those. That's fine, but for our use case, it's probably best to just use audiopus directly. So we have, for our two examples that we'll work with, Serenity, or Songbird rather, which is from the author of audiopus, and also OGG opus. And hopefully between those two, we can figure out how to encode our file. So we see that that's compiled. So we have over here our encode and decode functions using our really inefficient encoding. And so we're going to replace those. I'm going to make a file called internal encoding that contains these. We'll need to keep our these and call these like encode and decode v0, just because like we already do like support these. So when we load our database, we'll want to be able to convert those to the new format. All right, so I guess we at least need to keep the decode function. So add internal encoding as a module, and then we'll use v0 over here. Right, and these need to be public. All right, and now we can start working on an encode v1 function. So we can already see that here that we need to know the sampler rate when we start. So already this is not quite going to, like the same type signature isn't going to work over here. What I'm going to do instead is just take an audio clip. Just call it clip. And it's going to return a vec of U8. For now, and we'll see if that's enough. Okay, so we're going to create our encoder. So here it says Office Inc., but we saw that this was imported as audiopus coder encoder. We only have one encoder, so we can just use that directly. Let's see. Encoder new. So the first thing is the sample rate. And we see that there's actually a type for this. It's not just like a straight up integer, and we see that only some sample rates are supported. So we may need to, looks like we may need to resample it in that case. So I guess first let's do that. And there's a from, so you can convert from a number to a sample rate. Let's try that. It's a try from, so this is fallible, so it might return an error, so we'll need a result. Oops, result effect. 8, that's not the right result type. We want the type from error, just so we don't have to keep track of all the different result types that we could get. Okay, let's see if that works. Okay, it is not implemented for U32. Let's look at sample rate again. Looks like it wants to be an I32. There's try from for I32, so we'll try that conversion as well. This really should not fail because sample rates don't go that high, but just in case, we'll return an error if we can't convert it. Okay, right now it's, let's see. Right, let's try from here. Okay, but we want to actually not return if there's an error, we want to convert it if there's an error. So if we're okay, then we'll just return the sample rate. And if there's an error, then we will convert it. So we actually will also want the raw data. So we'll say samples and sample rate. So if we're okay, then we'll return, let's see, clip.samples and sample rate. And if there's an error, then, well, I'm going to get the lifetimes wrong and then fix them. So we'll do clip.resample to, well, we saw that 48,000 hertz is always supported, so we'll do that. Dot samples, and then also the sample rate as a audiopus type, which is this. All right, so the samples here, like this won't last long enough. We need to store this somewhere. So what I'm going to try is this. Let's see if that works. Consider use of lead binding. So like an unwrap that lets you like borrow. So like an unwrap ref or something. that's not going to work. Maybe it is actually. Okay. No, it does not live long enough. Maybe this works. Just kind of flailing a little bit. Okay, that's happy. And it keeps track of when it is initialized and that it's always valid. And we have our samples, which is effect of F32 and our sample rate. Wonderful, that's perfect. I think we will also need to return our sample rate. I'm just going to return that as a U32 because we may have re-encoded it, or resampled it rather. Okay, so next we can start actually encoding. Actually, no, we need to make our encoder. So we have our sample rate, channels. It's always mono. And application. So let's look at what that is. This doesn't actually say. So let's see if there's actually like documentation for the C function. And everything is set up right. So there is, look at that. So it talks about the applications here. And it does say, because of the enhancement, even at high bit rates, the output may sound different from the input. Use this, and then for audio, use this mode for music and mixed content broadcast and applications requiring less than 15 milliseconds of coding delay. So it sounds like VoIP might work, but I'm going to do audio just for the fidelity. Right, so that's like an audiopus application. Let's see, audio. And that is fallible, so we'll add our question mark. And now we have an encoder. Okay. Next step is set bitrate. So Opus has a file about some recommended settings for like how to tune the encoder. And it says for like something like audiobooks or podcasts that are mono, 24 kilobytes a second is great. So we're going to do that. These kind of settings obviously would not make sense for like something that was like a professional audio or like music application. But that's not what we're doing. We're analyzing voice. So we can be a little bit more efficient, or a little bit, we'll have a little bit better compression. Let's see. Why isn't there an option to import that? Oh, there we go. It's the last one. Bits per second, it looks like, and we're using 24,000. Great. So now we're done with that. What else do we do with an Opus encoder? Looks like the remaining thing is encoding. So here it's encoding a single packet with some samples, and it's passing it to the output.asmute slice. So we need to know what size to do this. I'm going to also look at this example. And you can see there's also an encode float function, which is probably what we'll want to use. And we see here it can fail, and if it does fail, this makes the last frame bigger and tries again. So if we don't have enough size, if we don't have a big enough size for our output buffer, that's fine. We can just expand it. So yeah, it looks like we have our input, we have our output, and we iterate through the input, appending it to the output. So to do that, I'm going to make a variable to store our output in. we'll just start with vet.new. The index of our samples and the index that we're at for our output. And so yeah, let's go. So while we still have samples left, we can try encoding. All right. Again, I'm going to not only look at the documentation from Rust, but also the documentation from like the original library, just to try to get a full understanding of this. So here it says the input signal will be encoded into the output payload, and on success returns the length of the encoded packet. And we can see from here on failure, if there's a buffer due to small error code, we know that's that we have to resize our output buffer. So if we look at opus encode float, or what we're passing to at least, we do pass it the length of the input divided by number of channels. That's 1 for us, and the length of the output. And it does say here that like we have to have certain frame sizes. They're not all valid, just some of them are. So that only has fixed values. For the and that also means that for our last frame, we'll need to pad it with zeros. It's not like just anything that's valid. There's also max data bytes, and it says that this is not used to control the bit rate. If it's too small, we'll just get an error. But that does mean that we have to be very careful about the size of the input. We can't just pass like as much as possible. We need to give a certain size. So if we look at here and we look at the valid frame sizes, it says that 20 milliseconds is a good default. So we'll do that, but we need to figure out how many frames that is, or how many samples that is. So that'll be our sample rate, divided by 32, just to convert the enum into an I32, divided by 1,000 because we want it in milliseconds, times 20 milliseconds. And that's going to be useful as a usize. So we can see based on all the valid sample rates that dividing by 1,000 is going to always give us integer numbers, so that this is safe. Okay, so what are we encoding? We are encoding. Let's just go with the happy case first, and then we'll look at what happens like for the very last one. So there'll be samples I, 2, but not including samples I plus frame size. Okay, and we want to encode that into our output buffer. Something like that. So there's a few problems with this. The first problem is that samples plus I plus frame size might be beyond the end of samples. So we need to cover that. So to do that, we'll say if samples I plus frame size is less than samples.len, then this is totally fine. Otherwise, well, we need to copy this to a new buffer because we can't just extend samples because it's immutable. So I'm going to make a new buffer just for that. And buffer it's the buffer that we'll use for the last last frame, and that's going to just be frame size. Then I will say, okay, for I in 0 to, well, we need the number of samples remaining. So samples.len minus samples I. We're going to copy that to end buffer. And so that will be, let's see, samples I plus I believe. And then we'll return a reference to our end buffer. Okay, I want to get this line ready first, so I'm just going to get rid of the error about the missing match arms. Okay, it looks like this needs to be mutable, so we'll do that. Okay. Let's try implement. So this looks good. Let's try implementing the different branches. So going back to our songbird example, if it's exceeded, then well, it's going to it's resetting to the start of the frame position. For us, we're just going to want to continue reading from the same input. So samples I plus equals frame size, output I plus equals packet length. Okay, and then I guess opus there is probably yeah, they're importing audiopus error as opus error. That sounds like a good idea. And error code as opus error code. All right. Oops. So now we should be able to do, let's see, opus error, and then an internal error, opus, and then opus error code. Buffer too small. Then we need to make the buffer bigger. And if something else went wrong, then I think we should just return that. And we can import that like that. There we go. Okay, so it's like looks like you're manually copying between slices. Wants us to use clone from slice. So hopefully that's more efficient. Great, I'm happy to do that. I love Cliffy. Okay, so buffer too small. In this case, we need to make our output buffer bigger. One way I'd think about doing this is like doubling it. But it starts at a size 0, so maybe we should give it a non-zero to size to start with. What I'm actually going to do is start with samples.len, and in case we're very small, to avoid like doubling a ton of times, I'm going to also just say like, if it's under 128, just make it 128. And this way we can just double the size if we need to. And we need to fill it with empty bytes. To Though if this happened, it's a bit odd because it means that our compression is not working very well. So we'll just neg that. Okay, so once we're done with this, we can truncate our output. Let's see. Oh, I forgot the exclamation mark there. Truncate to the size of output I, and then we can return it. Okay, so there's a couple of problems here with our encoder. Some things are missing. The first is we have no way to tell when we are done with a packet. So we need to encode the lengths of these packets. So to do that, what I'm going to do is use the first 2 bytes of our packets to encode the packet length, or like the 2 bytes before the packet rather. So to do that, I'm actually not going to write to output I, I'm going to write to output I plus 2. In this case, we also need to increment output I by the packet length plus 2 to account for that. And then we will write the length here. So a U8 is not big enough to encode all valid packet lengths, but a U16 is. So we'll do left bytes equals U16 try from packet length. And if I'm wrong about that, we'll just fail. And then 2 big endian bytes. And then we're going to write those. So output I is equal to bytes 0, and output I plus 1 is equal to bytes 1. Great. Now the second problem is that we are filling the end with silence by up to just under 20 milliseconds. And so we don't want that, when we're decoding that, we don't want to have to keep that padding. We'll want to get rid of those, which means we need to store the number of samples. And we're going to do something similar to what we did here, and just store the number of samples at the very beginning of our encoding. So to do that, I'm just going to make a new context here just to not keep those variables around out of scope. Okay, so this is a U size. I think that like U size on this computer is like 8 bytes, which is a lot. We can store it just fine in a U32, I think. So I'm going to do try into and try into a U32. Let's see, so we'll call this samples, then we'll say bytes is equal to samples of 2B bytes. And we can see here that this is, let's see, actually, let's look at this. It's not actually saying that it's 4 bytes, but I know it's 4 bytes. So then we'll say the first 4 bytes of the output. We learned about quantum slice below, so we're going to try using that. Sorry, I meant output. Why was I saying output I? Bytes those first 4. And then output I plus equals 4 to account for that. All right, so I'm just going to document those. So we're starting with 4 bytes, representing the number of samples as the U32 in big endian. And then for each packet, 2 bytes, number of bytes in packet as a U16 in big endian, and then the raw packet. There we go. Okay, so with this we should be able to make our decoder. So it's going to take a sample rate as a U32, and also the bytes. And it's going to, well, ideally return an audio clip. Or we'll eventually want an audio clip, but I'm just going to return the samples here. Okay, so same thing here. We take our sample rate. Let's actually look at the decoder in OGG Opus as our example. So it's taking a sample rate in channels, but doesn't need the application type. So yeah, we do need our sample rate. Sample rate is equal to sample rate dot try from, and we're just going to fail if it's invalid. And we're going to make our decoder. Which takes our sample rate, mono, and we don't have an application type. I don't think the decoder has like a set bitrate thing. Yeah, so we don't need to set the bitrate on the decoder. That's only something that matters for the encoder. I forgot a character there. Oh no, I just got the wrong character there. All right, I'm not sure if we need the frame rate yet, but we'll just check. Okay, so we can start reading, well, okay, so let's see. We'll have an iterator for bytes that starts at 0. And the first 4 bytes is the size of, or is the number of samples. So we need to assert that there's at least 4 bytes. But then we can just do, let's see, num samples is equal to U32 from big endian bytes then we just have byte 0, but nope, that wants an array. So let's see, does this work? Or it wants a slice rather. Looks like that works. Okay, so now our output can be, or we can say, I'm just going to call this samples, can be num samples might need to be a little bit more. We'll truncate at the end, but we're going to increase it by the frame size, just in case we have that partial frame size at the end. Okay, that doesn't work. We'll just spell out explicitly. That's not a reference. And we will make this AU size so that we can use it to index arrays. Okay, so we have samples I, and we'll have bytes I. And while we're not at the end, we're going to decode. So for the beginning of each packet, oh yeah, right, and we're actually starting, we already did bytes I, and I think you can always cast the U32 into a US size, but in case, maybe not on some platforms, in either case, we'll just return an error if we can't. Okay, so now we're going to get the packet length. So that this will be in 2 bytes. We could do a check like we did above, or we could use like data.get. So I'm just going to use data.get. Okay, so if we got both bytes, then that will be just a U16 from the big endian bytes. And it wants an array with A and B. And we want a U size. And if one of them is none, at least one of them is none, then the encoding is valid, invalid. Forgot a comma here. Just need to move the comma apparently. And I called this data, but I meant bytes. All right, at that point we can move bytes I over by 1, or by 2 rather. We now need to assert that there is enough size for the packet. And that there's enough size for the output. Very creative error messages, but it will do the trick. Okay, now we can try decoding, I guess. So decoder. decode flow along. Okay, so it wants a packet. Let's look at it wants an option packet. Let's look at documentation. This isn't very helpful. Let's look at the raw documentation. It says, use a null pointer to indicate packet loss. We are not a network application. There is no packet loss. So there'll always be some. Now we need to look at packet. New type is just the wrapper around a type, around reference to a U8. U8 slice to guarantee minimum one element and limited size. So there's a try from a U8 slice or a reference to a vec U8. So we can use either of those to get a packet. So it's going to look like some let's see, packet try from, which is fallible. Let's see, and this will be our bytes I plus, or bytes I2, bytes I plus packet length. Okay, next thing is outputs, which is a mute signal. I'm not sure what a mute signal is. Let's look at that. Oh, same thing. It's just a reference around our output. And we know the exact size of this. Actually, can we just pass the whole thing? Let's see. Let's look at decode float. So it is passing the length of the output there. Okay, so again, it's expecting the frame size to be correct. So we can't just pass the rest in. The size of this does matter. So output I plus frame size. Okay. And it is fallible. I don't think we're expecting any errors here. Let's see if this handles any errors. That does not handle any errors. I'm just going to assume that if something went wrong, that's not a problem. And it returns the actual output size. I guess it might not read an entire frame or something. In either case. I'm just going to assert that and you'll see something went wrong, but I'm just going to assert that this is actually the same as frame size, and if not, then we did something wrong. All right, and then so none of this applies. We will need to increment bytes by the, I said package length, no, packet length, and output, or bytes I rather, plus, why do I keep on saying output I? Oh no, it's right. Oh no, why do I keep on saying output I? It should be samples I. And at the end, we want to truncate it. And we can return our samples. takes 3 arguments. The first is the third is FEC, which is not documented here. Again, we'll look at the raw documentation. Flag 01 to request that any in-band forward error correction data be decoded. So I think that this doesn't apply because we're not losing data. Right, and that is solvable. And it's complaining that we're not using those. So before we go about updating this in our database, I think we want to just test this. So in main, I'm going to look at our record command. And by test, I'm not going to write unit tests in this video. Instead, I'm just going to encode it, decode it, and make sure it still sounds okay. So we take a clip. So we have the sampler rate and we have our bytes. And then we can try decoding it. And this takes our sampler rate and our bytes and gives us samples. And then clip 2 can be equal to audio clip. Let's see. Sample rate equal to SR, sample is equal to that. What else is there? ID is equal to the original clip's ID. Name is equal to original clip's name, and date is equal to the original clip's date. And we'll try playing this. All right, let's see how well we did. Right, that should be our fence. All right, testing. So we successfully encoded it and decoded it. So we can update our database now. Okay, so in this first version, we set user version, which is 0 to start with, and when we initialize the schema, we set it to 1. So what we want to do is we want to get the user version before all of that to know if we need to update the database or not. If we just made our change here without updating the schema and updating any of the rows which need to be changed, then our databases from older versions be invalid. So we're going to do our first little mini migration. So we'll say user version is equal to connection dot pragma. Okay, so pragma query looks promising. Let's look at the documentation a bit more. It wants a function. Okay, so it says select star from pregnant collection list is better. So let's look at that. Oops. Okay, and so this is just saying that we can select those directly. So we'll do that instead. So we'll go connection dot query row. That's just going to query one single row. Maybe select user version from Craig my user version. And then we get our results. Or yeah, there's no params. And we get our results. Get the first column. Let's see, and it's probably fallible, and hopefully we can cast this to like a U32 or something. And it looks like that worked. Okay, we're going to set it to 2. We're going to say if user version is less than 1, so if we're just initializing it, then we need to create the table. And if user version is less than 2, then we'll need to update the table to have our new, or to rename, we'll need to take all of the samples we have, re-encode them, take all of our new samples, re-encode them, and then update the name of samples to something like encoded data or something. So for this, SQLite offers an alter table instruction. And it has a rename column thing. Actually, I'm just going to call this opus. There are no arguments, and it is fallible. Before I forget, I'm just going to create a copy of this in case I mess up and need to try the migration again. Okay. That looks okay. I'm going to also query all of our, we want to load all of our samples. Let's see. So we could use list and load, but we're going to change load to use encode v1. So I'm just going to do this directly, like copy this. All right, we are loading all clips, not just one of them. We want connection, not self.0. And we're using decode v0, that's right. And then we're going to take this logic, which, and then we're going to use the encode function rather to re-encode it. Actually, no, we can just get our audio clips. Let's put this in a vector. What is this complaining about? Unused variable class. Okay, no, that's all good. Just the no need to be vector. And then we're going to save all of these. So we actually have a save function, so we're going to use this. But instead, we're going to first re-encode this. So that is, I actually lost it, but that's okay. We're going to do sample rate bytes is equal to encode v1 clip dot, or just we're taking a clip. I think that's already a reference. And we're just going to save the sample rate and the bytes. And this is fallible. Okay, now that we've encoded everything, we can update the v0 functions to be the v1 functions. So we give it our sampler rate and our bytes. And there's also decode. So we have our sampler rate, which we need for the decoding. Which I believe is 32. And samples. Which takes our sampler rate and our bytes. Amazing. And we renamed samples. So I'm going to fix that and instead now use opus. This is still samples because it's before we renamed it. All right, let's see how this goes. Right, we don't need encode v0. We can actually just get rid of that. If we ever do need it, that is still in Git history. And it might make for a useful test, which I'm not actually going to do. Right, that is fallible as well. Right, this is the same issue that we had before with it not being an error. It's a rusqlite error, so we need to convert it. Okay, and I think we want some kind of notification that we're updating the schema. And also that we're initializing it. Okay, let's try listing things first, just to see if updating the schema seems to work. All right, so it did update it. If we run it again, it doesn't update it. We can try playing our first clip. All right, our recording is that looks good. We can try recording a new clip. This is a new clip. This is a new clip. All right, so it looks like everything's working great. So I'm going to end the stream here. Thank you so much for watching.